All right, 2.4, real zeros of polynomial functions. I don't think we're going to do this whole section today because there's just kind of a lot in it, so we'll probably extend it out to Monday. But we'll just see as we go what's happening. Divide using synthetic division, write a summary statement in fraction form. So we did a little bit with this last year in Algebra 2 or college algebra. We did in both, but not as much as we'll end up doing with it in this chapter. So number 8, I've got 2x to the 4th minus 5x cubed plus 7x squared minus 3x plus 1 divided by x minus 3. So synthetic division, we always only use the numbers, not the variables. If there's a term missing, we have to plug in a 0. And when we do the box, whatever goes in the box has the opposite sign of whatever this is here. So we put a positive 3 up here in the box because this was negative. So that's kind of our what we're dividing by. And then these need to be in standard form. So if they're not in standard form, you need to put them in that. And then it'll be 2, negative 5, 7, negative 3, 1. So that's the setup. And so keep in mind that this is an x to the 4th term, and it's not, it is relevant to what we're doing today, but it'll be even more so relevant to what we're doing for the rest of the chapter. But in terms of how we write our final answer, we'll need to know that. So we bring down the first number exactly, so that just brings down the 2. Multiply by 3, so that's 6. And then minus 5, so that's 1. Times 3 is 3. Plus 7 is 10. Times 3 is 30. Minus 3 is 27. Times 3 is 81. Plus 1 is 82. And so the number that's left over here is the remainder. So our final answer, if this started as an x to the 4th term, this is now an x cubed term. So my answer is going to be 2x cubed plus x squared plus 10x plus 27. And then I've got to still account for this remainder, so we write plus or minus, depending on what the sign is here, but in this case it's plus 82 divided by x minus 3. And so this would be my final answer. Does this ring a bell from last year a little bit? Okay, good. Yeah, it's kind of enjoyable because it's kind of like easy math.
Exactly.
Other than setting it up and stuff, but. Let's look at another one. 10. 3x to the 4th plus x cubed minus 4x squared plus 9x minus 3 divided by x plus 5. So one of the first things I always do is look and make sure that the terms are first of all in standard form, and then also that there's no terms that are missing. I don't have any missing terms, so I'm good to start. So up in the box, I put a negative 5. It's got to have the opposite sign. And then just copy the numbers with their signs from up here. So 3, 1, negative 4, 9, negative 3. Bring down the 3. Times negative 5 is negative 15. Plus 1, negative 14. Times negative 5 is 70. Minus 4 is 66. Oh, goodness. Times negative 5, negative 330. Is that right? Okay. Plus 9, so negative 321 times 5. Oh, goodness. Okay. Okay, it's going to be positive, so let's see. 5, 10. You say 1605? Okay. I think so, too. I just wanted to verify. minus 3, so 1602. So that's our remainder there. Get comfy for math class.
Yep.
So our answer, this was an x to the fourth, so this is now x cubed. So 3x cubed minus 14x squared plus 66x minus 321 plus 1602 divided by x plus 5. All right, one more of these ones. Number 12. X to the 8th minus 1 over x plus 2. What do you notice about this one? It's missing a lot of them. So, I put negative 2 in the box. The first term is x to the 8th, so I put a 1 there. I'm missing x to the 7th, x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, and x, and then I have a constant term. So I set it that way so you can make sure you put a 0 everywhere that there's a missing one. So in total you should have 7 zeros in there. It's really annoying when you think you have them all and then you realize you missed one. So that's why I say it out that way. So bring down the 1. 1 times negative 2 is negative 2. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Times negative 2 is 16. Times negative 2 is negative 32. Times negative 2 is 64. Times negative 2 is negative 128. Times negative 2 is positive, 256? Minus 1 is 255. So that's your remainder. And then this answer is obviously obnoxiously large, but this was x to the 8th, so this is now x to the 7th. So x to the 7th minus 2x to the 6th plus 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128 plus 255 over x plus 2. Now, I usually won't give you one that big on a quiz or a test because, let's be real, that's kind of a miserable problem because there's so many pieces. But I wanted you to be aware of what you need to do if you have something like that. All right, the next problems want us to use the remainder theorem to find the remainder when divided by x minus k. So remember, the remainder theorem is you just take whatever number they give you and we plug it in for x and we get an answer, and that's our remainder. And the way that they give it to us, they're giving it to us RD and K equals form, so we won't have to change the sign on it. 14, f of x equals x to the 4th minus 5, k equals 1. So I just plug in 1 for x, so f of 1 equals 1 to the 4th minus 5. So 1 minus 5 is negative 4, so the remainder of that problem would be negative 4 if you were to actually divide it. 18 f of x equals x to the 5th minus 2x to the 4th plus 3x squared minus 20x plus 3, and k equals -1. I thought you were giving her crisscross braids for a hot second, and I was like, you're getting really fancy over there. I've tried to watch videos of them, but I haven't been able to figure it out. All right, so we plug in -1 this time. So -1 to the 5th minus 2 times -1 to the 4th plus 3 times -1 squared minus 20 times -1 plus 3. So I've got -1 minus 2 plus 3 plus 20 plus 3. So that's 23. So that would be the remainder on that one. All right, and then I think the last thing we're going to do today is the factor theorem, and then we'll just kind of stop there, and then we'll pick up with the rest of it on Monday. That's kind of a good like midway point of the section. The factor theorem says that if essentially when I plug in k, that the result is equal to 0, then it is a factor. If it's not 0, it's not a factor. So they tell us that 20 x minus 3 is the factor that they're wanting us to check, and it's x cubed minus x squared minus x minus 15. So notice this is x minus k, so if I set that equal to 0, that's how I would actually find what k is equal to. So I need to change the sign on this, so k is equal to 3. That's the opposite sign. And then I just plug that in. So 3 cubed minus 3 squared minus 3 minus 15. So 27 minus 9 minus 3 minus 15 is equal to 0. So yes, this is a factor. And I'll do one more, and then Emma, you can go after that if you want. We're just doing one more. 24 x plus 1, and then I have 2x to the 10th minus x to the 9th plus x to the 8th plus x to the 7th plus 2x to the 6th minus 3. So what is k going to be for this one? Yep. So opposite sign. So k is -1. So I have 2 times -1 to the 10th minus -1 to the 9th plus -1 to the 8th plus -1 to the 7th plus 2 times -1 to the 6th. Hello? It disappeared. Minus 3. So then -1 to the 10th is just a positive 1, so that's 2. -1 to the 9th is a -1, but it's being multiplied by a negative, so that's positive 1. -1 to the 8th is going to be positive 1. -1 to the 7th is -1. -1 to the 6th is positive 1 times 2 is 2. And then minus 3. So was that 3, 4, 3, 5, 2. So that's equal to 2. So is this a factor? No. It's only a factor if it's equal to 0. Yeah, I'm going to write down the problems for where we're at. But you'll turn them all in together so you don't have to do them, like, over the weekend or anything. 7, 9, 13, 17, 19, and 21. If you want to take a picture of it, you can.
What class is this?
Pre-cal. So we'll pick up with the rational zeros theorem and stuff on Monday. We will probably quiz on Wednesday on 2.1 to 2.4.